Good morning, students. Myself S. Muthukumar, Assistant Professor, St. Joseph Institute of Technology. So, in the previous session, we have discussed the basics of data link layer. Today, we are going to discuss the main functionalities of data link layer. So, we already know that the main purpose of data link layer is node-to-node delivery. So, how it is performing the delivery of packets? So, it receives the packets from the network layer. So, here we are getting the packets from the network layer, then that is given to the data link layer. So, here the data are called as frames. So, what is the need of frames? So, to manage the delivery of data, we are using the terms called frames, that is manageable smaller units. We know that we are delivering the message from sender to receiver in the form of signals. So, this is the form of signals. We know that the form of signals are zeros and ones. So, while transmitting the data, any signal loss may be happen because of noise. So, due to noise or interference, any signal loss may be happen during the transmission. To ensure the data delivery with reliability, we are going for some mechanism that is called as error control mechanism. So, this is nothing but it's a process of detecting the errors as well as correcting the errors. That is comes under error control mechanism. So, we have already discussed the basic functionalities of framing and flow control. With the continuation of that, we are going to discuss about error control. This is called as error detection and error correction. So, these two tasks are combined as flow control. So, we are ensuring the reliability of delivery of data to the receiver from the sender end. So, here the message is called as data bits. Data units are data bits. Some keys are shared with the sender and receiver. This key is shared only between the sender and receiver. So, some operations are done with the data bits with this divisor or key that is known only to the sender and receiver. So, some operations. Here we are going to perform some operations. Binary division or some operation additions. So, we can choose any type of operations. So, this is the basic task of sending the message. Okay. So, what is error? We already discussed this is the interference. So, due to the interference, some signals may be changed. So, if I am sending this signal, but the signal is like this received at the receiver end. So, this is due to some errors. Okay. So, for example, I am sending this bits, but these bits are changed like this one. So, note on the bits, here 0 is there, here 1 is there. So, here again 0 is 1 is there, this is 0. So, some bits are changed. If only one bit is changed, then that is called as single bit error. If multiple bits are changed, then that is called as multi-bit error. Sometimes multiple consecutive bits are changed. For example, 100, 1001. So, if I am sending this data 111, 101, continuously 2 bits. So, randomly some bits are changed or continuously some bits are changed. So here 001 is shifted to 110. So continuously 3 bits are changed. This is called as burst error. I hope you have understood the basics of errors and types of errors. Next we move on to the next topic. How we are going to provide the reliable data to the receiver. So the simple thing is we are going to add extra bits, that is called as redundant bits with your data. So we have a sender and receiver. So while transmitting the data to the receiver, we are going to add redundant bits with your data units. This redundant bits is only known to the receiver and sender. So how to add this redundant bits or extra bits? Can we add a single bit or a group of bits? How to add the redundant bits? So for that we have to follow some rules and regulations. That is called as error control mechanisms. So the famous error control mechanism is CRC, cyclic redundancy check. So what we are going to do this in CRC. So we are going to add redundant bits, but we are adding more bits here. We are not going to include a single bit. We are going to add multiple bits. Okay, how to choose that multiple bits? Is there any procedure for adding that redundant bits? Yes, of course. We have to follow some basic rules. So we will discuss the rules. So rules for selecting the redundant bits. So consider this message bit and key. So some key values and data bits are given for transmission. So consider this is a single frame. So we know that in a data link layer we are calling the data units as frames. So we already discussed in the previous session. So frames. So we are going to add some units with these frames. So by applying some key value. So in the CRC, first we are going to find the number of bits in a given key. So here the key is called as divisor. The message unit is called as dividend. So because here we are going to apply binary division or modulo division. That's why the message unit is called as dividend and the key is called as divisor. First we have to find the length of the divisor, that is L bits. Then we have to find the number of redundant bits. That is CRC. So the CRC is the final result, that is the remainder value. Then what is the use of this length of the divisor? So the length of the divisor is used to add the number of zeros with your actual message. So L minus 1 bits zeros are added with message. So note down, this is not a redundant bit. So we are going to add extra zeros with the message. That means we are going to add message and extra zeros. So the number of zeros is based on the length of the divisor. So L minus 1 bits are added with the message. For example, if message is 10101. The divisor is 1010 means you have to find the length. So length is 4. So 4 minus 1. So 3 bits. So 3 zeros will be added with the message. Okay. So we have discussed the number of steps. First we have to find the number of bits in a divisor, that is in a key. Next we have to find the number of zeros that should be added with the data unit. Note down, this is only for division. This is not an redundant bits. We are going to find the redundant bits, that is extra bits. So that is using binary division. So we are taking the data units as a dividend and we are taking the key as a divisor. We are going to apply modulo 2 division or binary division. So take on. So here 2 components are there. So one is act in the sender side, another one is act in the receiver side. So that is called a CRC generator and CRC checker. This is at the receiver side. So this is at the sender side. So we are going to generate the CRC bit at the sender side and we are going to send with message with redundant bits and CRC checker will do the same operation and will get the result as a 0. So we are going to take the data units. So the data unit is 1000. So this is your dividend. So dividend is given data units. Any number of bits can be given. So take the divisor 1101. So we have to find the binary division. So for binary division we can simply use XOR table. That means X, Y and XOR of XY. So if it is same, so we are getting the 0. If it is different values, we will get 1. The same operation is used for binary division. So if both values are 0 in a dividend, so you will get 0 value. That means, so starts with the binary division. So 1 into 1101. So here 1 is same value, refer this table. So you will get 0, 0, 1. So normally we are considering only 3 bits. So we are not bothered about the last bits. So this is usual in division. So don't bother about this value if it is a 0 or 1. So mostly we are getting 0. So don't bother about the leftmost bit of, that is 4th bit. So this is your leftmost bit. Leftmost bit. So no doubt this is the leftmost bit. It should not be 0. If it is 0, you have to multiply with divisor with 0. That is the main rule in CRC. So here note down, this is 1. So no issues. So but we are having only 3 digits. So get the another digits. So note down, here we are apply only the message. We are not adding the extra bits. So if you are taking this format, we will get only the less number of values. So first you have to add the extra bits. So I have already told that number of bits is in the divisor is 4. So 4 minus 1, 3. So the number of extra zeros is here is 3. So you can continue the division operation. So get the next bit. So 1000. So next perform the binary division. 1 into divisor 1101. So perform the operation 0 into 1. So you will get 1. So again here 0, 1. Okay. So don't bother about the leftmost bit of this one. So here note down this is 1. So there is no issue. So you can continue the operation. So take the next bit. This is 0. So perform the operation 1 into divisor 101. So you will get the value of 1, 1, 1. So there is no issue. This is here we are getting only 1. So get the next bit. 0. So 1 into 1 1 0 1. So here we are getting 1 1, note down. Here you are getting zeros. So if you are getting zeros means you should not continue the operation with divisor. You have to multiply the divisor with 0. So if the leftmost bit is 0, so multiply with the 0. 0 into divisor, all zeros. So you will get 0, 1, 1. So get the next bit, that is 0. So continue the operation. 1 into 1, 1, 0, 1. So you will get 1, 0, 0. So this is your remainder. So at finally you are getting 0, 0, 1. This is your remainder. This is your remainder bit. So note down, all the bits are over. Here we have added extra 3 bits for division. So we are continuing the process. At the end we are getting number of bits as 3. So it should be less than equal to the L minus 1 value. That is the number of values in the divisor is 4. So 4 minus 1, 3. So we are adding 3 extra zeros. So at the remainder you will get the 3 bits as a remainder. So note down, this is your CRC. So don't confuse with the terms. This is not the CRC. This is your CRC. So finally you are getting the remainder, no? That is CRC. So this is added with your data unit. So here our data unit is 1000100. So here we are going to add 001. So this is your data plus CRC. So this is sent from sender to receiver. So at the receiver end, the message with the CRC is taken from by the receiver and the same binary division operation will be applied. So at the receiver again will perform the binary division. So you have to get the remainder at 0, all zeros. That means if you are getting the remainder as 0 means your data will be given to the receiver without any error. So we are adding the extra bits and we are finding the CRC and we are going to transfer the data with CRC value to the receiver. At the receiver end, again the same operation, binary division operation will be performed. Then you will get the remainder will be 0. If you are getting the remainder will be 0, then the data is transferred to the receiver without any error. Okay, we are done with the CRC generator and we have find the redundancy bit, that is CRC at the sender level. So now we are move on to the receiver level. So I already told that the sender will find the redundancy bit, that is CRC, and append with the data bits and forward to the receiver. So at the receiver end, again the binary division is applied with the data units with CRC. So at the end of the remainder, if we get 0, the data is transferred without any error. So we will check on it. Okay. So the CRC bit with data bits, that is get in the last CRC generator side is 100, 100 and 001. So this is your CRC bit that is obtained in the last CRC generator side. Okay. So now we have to check whether it is error free data or with errors. So move on to the checker side. So take the values 100 and 100 with CRC value. This is CRC value. Again apply the binary division. So we know that binary division is the format of XOR. So we know the XOR table already. So 00, 0, 1, 1, 0, 1, 1. So same value means we have get 0. If any input is 1 means we will get 1. So follow the same procedure with the same divisor. So we know that the divisor is a common key value that is shared between sender and receiver. Both CRC generator and checker use the same key as a divisor. So 1, 1, 0, 1, this is a divisor. So continue with the binary division. Binary division. Okay, starts with the binary division. 1 into 1, 0, 1. 0, 0, 1. So we know that we should not bother about the least significant of this bit. So this is the LSB. So in this example, this is LSB. So take the next bit, 0. So 1 into divisor, you will get some value, 1, 0, 1. So carefully note down the least significant bit should be 1. It should not be 0. If it is 0, it should be multiplied 0 with the divisor. So we already discussed in the CRC generator side. So 1, 0, 1, it consists of only 3 bits. So take the next bit, 0. So continue with the binary division. So 1 into divisor, 1, 1, 0, 1. So we are getting the some remainder value, 1, 1, 1. So here 0, 1, 1, 1, 0, 1, 0, 1 is 1. So take the next bit. Okay, so continue with the division, 1, 1, 0, 1. So 1, 1, note down. So carefully note down. Here left most bit or LSB is 0. If leftmost bit is 0, so multiply divisor with 0. Okay, then multiply the 0. So you have to put 0 here. So take the next bit. So I am taking the next bit. So this one over, this one over. I am taking this bit, and next we are taking this bit. Okay, 0 into divisor. So all zeros. Okay, now you get the value of 1, 1, 0. Okay, next take the last bit. So take the last bit. So 1 into 1, 1, 0, 1. So you will get the remainder as 0. So if the remainder is 0, the data unit is error free. If you are getting any remainder values like 0, 1, 0 or 0, 1 or 0, 0, 1, that is consist of error. So you can easily find out whether the error present in the data unit or not. Okay, we have discussed one exercise problem for CRC detection and how to handle the errors in a message. So sometimes to confuse the students, the data bit may be given in different format. For example, taken the data bit, this is the data bit, and the key value, that is your divisor key or divisor. So this can be given in the another notation called polynomial notation. Polynomial notation. So the data can be given in the polynomial notation. That means you have to find the coefficient of the polynomial equation. So we can write the message as polynomial format. So that means you have to write the coefficients. So x square, x cube, and so apply the values. So 0, 0, 1, 0, 0, 1. So in this polynomial notation, we can take in the message bits. Sometimes the message bit can be given as a polynomial notation. If you convert this message bit in a polynomial notation, you can write like x power 5. So we have only coefficient with x power 5. So x power 4 and 3 are 0. So there is no coefficient. So then x power 2. Then there is no x bit and last bit. So in this format also, sometimes the data unit given by the question. Okay. So note down the divisor 1101. So convert into polynomial notation. So here 1 x, then x square, x cube. So you can convert into polynomial equation, x cube plus x square plus 1. So in this format also, the data and the key shared by the sender and receiver, that is the divisor given in the question. So you have to concentrate on which units are available in the given data units. So if something is left in the polynomial notation, you have to add 0 as a bit. So this is based on the number of bits available in the polynomial notation. So sometimes this unit is not given directly. So sometimes you will left this portion. So you have to start from the unit, last unit, then x power 2, x power 3 and up to whatever the given. So in the previous question, we have taken only the 6 bits, 6-bit notation. So sometimes they given up to 16 bits also. 16 bits. So 16 bits polynomial notation also given in the question. So you have to carefully write the parameters. So can you convert this into the polynomial notation? So we can easily convert 1 x, so x power 2 is 0, then x power 3 and x power 4, 5 is 0, so x power 6, 7 is 0, x power 8, 9 is 0, x power 10 and 0, so x power 12 and 13, x power 14. So in this format also we can write the data bits. So don't forget the last bit. So you can give 8 bits or 6 bits or 12 bits or 16 bits data bit can be given. So you have to choose the divisor and the message bits carefully. So if suppose the polynomial notation for this message is given, the divisor is given like this: x power 5 plus x power 3, x power 1, that is x plus 1. So how many bits are available in this divisor? So sometimes we will make a mistake. So by calculating 1, 2, 3, 4, only 4 bits are there. So sometimes we will make the mistake. So we have to carefully write the divisor value. So x power 5 is available, x power 4 is missing, so x power 3, then x power 2 is missing, so x and 1. So number of bits for this problem is 6. So the message is 16 bits and the divisor value is 6. So carefully write the divisor value. So what about number of zeros added with the message for this one. So here the number of bits available, that is L value is 6. So number of zeros added with message is L minus 1, right? That is M. We take it as a M, L minus 1, 5. So we have a 16-bit message with 5 zeros will be added for CRC generator. So 16 plus 5 bits. So totally 21 bits taken for CRC generation. So in the CRC generator side, you have to take 21 bits, 16 bits from the given data polynomial notation and 5 bits, that is extra zeros added for the binary division. So continue with the binary division, you will get the CRC value, that is remainder. So what is the remainder value? How many bits should be available in the remainder? So it should be 5. How is it 5? Because number of zeros added with the message bit is 5. So your remainder should be 5 only. So remainder or CRC will be equal to L minus 1, that is M bits. So note down all these key points for making the CRC generator as well as CRC checker. So just recall the points. We have to take the message and we have to find the number of bits in the divisor. We have to add the divisor values, that is number of bits L minus 1 value to the message for CRC generation. Then we will get the remainder value, add that remainder value to the message and pass to the receiver. Then the receiver take the message plus CRC and apply this binary division. You will, if you get any remainder, then there is a error in the transmission. You should get the remainder as 0. Remainder value will be 0, all zeros. If you are getting any remainder value, means that frame is corrupted. That frame is corrupted. So you have to selectively retransmit that frame itself. That is the topic of error control. So we have detect the error as well as we are trying to correct the errors. If you have any doubts, we will discuss in the next session. Thank you.